writing equations in slope-intercept form. So we're going to take a look at situations where you need to create an equation. Slope-intercept form is kind of our basic go-to of equations. So if I need to write an equation, this generally is what we kind of start working with. It's a really friendly equation to work with. Our slope-intercept form, y equals mx plus b. M is our slope, b is our y-intercept. So we're going to write an equation in slope-intercept form when we're given the slope and a point. In order to write an equation, we really need two pieces of information. We can have 2 points, we can have a slope and a point, but we need to have 2 pieces of information in order to create an equation. That applies to word problems or kind of generic situations like this. So if we have a point 2, -3 and a slope of 1/2, we can start with our slope-intercept form, y equals mx plus b, and we're going to plug in what we know. Notice we've got a y-coordinate, a slope, an x-coordinate, and a y-intercept. 1, 2, 3, 4 things here. If I can fill in 3 of them, I can figure out the 4th one. So I have an x-coordinate, a y-coordinate, and a slope. I can fill in 3. So I'm going to put my x value where the x is, my y value where the y is, and my slope where my slope fits in. That leaves me only missing my y-intercept. So I'm going to do my math here. I'm going to do 1/2 times 2 and get 1. I'm going to try to get that, isolate that variable b by subtracting 1 on both sides. I get -4 equals b. So I have my y-intercept, I have my slope, they gave it to me right at the beginning, so I can plug those into my slope-intercept form. Y equals my slope, 1/2, times x minus, or plus a negative in this case. My y-intercept is a -4, so plus a -4 or -4. So there's my equation that represents the line that goes through this point with this kind of a slope. This equation now represents every point on that line. Where this situation was talking about some specific pieces, this I can use to figure out any point that will be on that line. All right, let's try it with another piece of information here. I've got an ordered pair 1/4, and I've got a slope of -3. Again, we're going to think about our slope-intercept form here, y equals mx plus b. I'm going to take my ordered pair, plug my y-coordinate in where the y is, my x-coordinate in where the x is, plug my slope in where m is for slope, and that leaves me with a missing unknown variable b. So I'm going to do my algebra here, multiply, add 3 to both sides to isolate the variable. I end up with b equals 7. So now I have my y-intercept, and I have my slope that they gave me to start with. I can plug those into slope-intercept form and come up with an equation that's y equals -3x plus 7. Done. All right, what other pieces of information might they give us? So they could give us a point and a slope. They could just give us 2 points. So if we're given 2 points, we're going to write an equation for that. So let's work with slope-intercept form, very friendly equation to work with. I have these 2 points here. So one thing I can find out from those 2 points is the slope. I can use the points they gave me to actually find the slope using our slope formula. So I'm going to plug my points into slope formula here, m representing slope, y2 over y2 minus y1 over x2 minus x1. So remember, this is one of my ordered pairs here. I put the y in the numerator and the x in the denominator, subtracted, and then behind that I've got my y in the numerator and my x in the denominator. So this is an ordered pair. This is another ordered pair. It's an easy way to check to make sure your number's in the right spot. Do my math here. I come up with 4 over -1, so my slope is -4. So now I'm back to where I was before. I know a point and I know my slope. So I know my slope is -4, so I can plug that into my equation. I actually know 2 points at this case, so I could use either one of them. If one is more friendly than the other, go ahead and use it. Both of these points are on the line, so both of these points will give you the same y-intercept once you do the algebra for this. So if I plug in my -4 for y, my slope, my x-coordinate, and my variable I'm going to keep for my y-intercept, I'm going to do my algebra through here. And once I work through, I end up with my y-intercept is -16. So now I go back to my slope-intercept formula. Again, I know my slope and I know my y-intercept. I'm just going to plug them in. Y equals -4x minus 16. This is a really nice plug-and-play equation. We just take that form, we plug the slope in, we plug the y-intercept in, and then right there we're done. Pretty straightforward. Let's try this one more time. I've got 2 ordered pairs here, 6, -2, 3, 4. I'm going to start by finding the slope. I plug my y over my x, I subtract, I put my y in over my x, I do the subtraction, I end up with a slope of -6 over 3, which simplifies to -2. I'm going to come down to my slope-intercept form here. I'm going to plug in one of my ordered pairs. I use the second ordered pair just because it was positives. I easily could have used the first ordered pair. I should have still come up with the same y-intercept. Plug those values in here. I solved my equation for b. I ended up with a y-intercept of 10. Go back to my slope-intercept form, plug in my slope that I found earlier, plug in my y-intercept that I found at the end here, and I end up with an equation y equals negative 2x plus 10. These should be really easy to check also. If you're not sure if it's right, it doesn't really feel well, go up and take either one of these points, or both of the points, put them in here for x and y. This equation should be true, so let's try it. If I take negative 2 and plug that in there for y, and I take 6 and plug that in here for x, negative 2 times 6 gives me negative 12. Negative 12 plus 10 gives me negative 2. It should work for 3, 4 also. Let's try it. Y equals 4, so I have 4 equals. I'm going to do 3 times negative 2 plus 10. 3 times negative 2 times 3 gives me negative 6. Negative 6 plus 10 gives me positive 4, which is what I was hoping for as an output. So your equation, again, represents all the points on that line. Since these are 2 points on the line, those points should make this equation true.